Welcome. This is lesson 4.4, the slope of a line. So listen carefully and make sure you get all the notes copied in. First up, the slope is the steepness of a line. It is the number of units the line rises or falls for each unit of horizontal change from left to right. The variable used to represent slope is the letter m. Now, what does the slope tell us about the actual line? Well, the slope tells us a little bit of everything. If the slope is positive, then from left to right, the line will rise. If the slope is negative, the line will fall. If the slope is 0, the line is horizontal. And if the slope is undefined, the line is vertical. And you may remember from earlier this year, undefined only happens when 0 is under the line. So if 0 is under the line, it's undefined. If 0 is under the line, it's undefined. Now what we have is our slope formula. The slope formula uses two sets of ordered pairs, x1 and y1 and x2 and y2. And the formula is y2 minus y1 over x2 minus x1. Then you're just going to have to reduce that. And then you're going to write whether it rise or fall, horizontal or vertical in those cases. So we get a chance to see what type of slope or what actually happened in the slope. Okay? So the first thing we would do is we would mark up our points x1, y1, x2, y2. Then we would take those points and put them into the formula. Then we would do our operation, -3 minus -1, which gives us -4. And we would do 1 plus 2, which is 3. So our slope is -4/3. So because it's negative, that means that line will fall. Now in our second example, we have 1, -3, and 0, -5. So this is x1, y1, x2, y2. Plugging it into the formula would be -5 y2 minus y1, which is -3, over 0 minus 1. So this would give us -2. And on the bottom, we would have -1. Now, because there's two negatives here, this actually reduces to +2. You can also write 2 over 1, but it's completely fine to just leave that as +2. Now, because it's a positive slope, this line will rise. Our third example has 2 points, 2, -1, and 2, 5. I'm going to mark them as x1, y1, and x2, y2. So we would have 5 minus -1 over 2 minus 2. So the top would become 6, the bottom would become 0. Because 0 is under the line, the slope is undefined. Now, if it's an undefined slope, that means it would be vertical. give us a vertical line in that case. Okay? In 4, we would mark up our points, x1, y1, x2, y2. We'd plug them into the formula, -4 minus -4 over 1 minus -7. This would give us 0 on top and 8 on the bottom, and 0 divided by 8 is 0. So because we have a slope of 0, we would have a horizontal line. Now, example 5 and 6 might look like a funny way of writing points, but they are points. It's called function form. So all you do is you take function form, and the first thing is x, and the second part is y. So the point we're actually looking at in 5 is -9, -3, and 9, 3. Now we treat it just like any other problem. This is x1. This is y1, this is x2, this is y2. So it would be 3 minus -3, careful of your signs, and 9 minus -9. So this becomes +6 on top and +18 on the bottom. But that can be reduced to 1/3. So that's the slope of this line. Because it's positive, the slope would rise, or have the line rise. In 6, we would have the 2 points, 6, -1, and 3, 8. This is x1, this is y1, this is x2, this is y2. We would take our 2 points, plug them into the formula, 8 minus -1 over 3 minus 6. So this would give us +9, and this would give us -3, which would reduce to -3 or -3 over 1. Because the slope is negative, the line will fall. So if you would, flip those sheets over. And that leads us to types of slope that have parallel and perpendicular lines. Okay? So, parallel lines have the same slope. And perpendicular lines have opposite reciprocal slopes. So opposite means one's positive and one's negative. Reciprocal means that the fraction gets flipped. Okay? So we have 2 lines, and we have to decide if they're parallel, perpendicular, or neither. So in number 7, the first line, we have -3, 3, and 3, -1. So I'm going to plug those points into my formula, -1 minus 3 over 3 minus -3. So my first slope is -4 over 6, which is -2/3. Okay, that's the slope of line 1. Now line 2, I'm going to plug in x1, y1, x2, y2. Plug them into my formula. 3 minus -3 over 2 minus -2 would give us 6 over 4, which reduces to 3 over 2. Because these slopes are opposites, one positive and one negative, and reciprocals, so one is 2 over 3 and the other is 3 over 2, these 2 lines would be called perpendicular. All right, our next example, again, is two points, or two separate lines, and we're going to find the slope of each line. So for line 1, the slope would be 4 minus 1 over 3 minus negative 3. So that gives us positive 3 over 6, which is 1/2. Now for line 2, I'm going to mark it up, x1, y1, x2, y2. That would be 1 minus negative 3 over 4 minus negative 4. So that would give us positive 4 on top and 8 on the bottom, which reduces to 1/2. Because these two slopes are exactly the same, the two lines are parallel. And then the last part of our note today is we're going to take a look at word problems with slope. Okay, so it says you are typing a paper at 5:15 p.m. You have typed 275 words. By 5:27 p.m., you have typed 660 words. Find the average change in words per minute. Okay, so what that means is that we want words on top and minutes on the bottom. So to figure out how many words per minute, you take 660, which is what you end it with, minus 275 over, it would be 527 minus 515. So the bottom, it's kind of easy because that's just time element. The top would be 660 minus 275, which gives us 385. So right now we know we do 385 words, and on the bottom we found out that was in 12 minutes of work time. So if we want to figure out how many words per minute, we would take 385 and divide it by 12. So that gives us 32.08. So we're going to round that off to about 32 words per minute. And our last one here is you're traveling by car and you leave your house at 8 a.m. By 8:45 a.m., you are 36 miles from your home. Find the average speed in miles per hour. So we want miles on top and hours on the bottom. So we know you've traveled 36 miles. We don't even have to do any computation for that, which is nice. But you've traveled for 45 minutes because you went from 8 to 8:45, so that's 45 minutes. Now, they want it in miles per hour. So 45 minutes is not a full hour. So 45 minutes out of 60 is actually 3/4 of an hour. So now we would take 36 and divide it by 3/4, because that would give us the miles per hour. So we're going to take 36 divided by 3/4, and that would give us 48 miles per hour. Now the rest of the class, you're actually going to practice just the slope. You're not going to have to worry about parallel and perpendicular lines or application problems. You're just going to practice the slope formula given 2 points. And we'll go over more of the other types tomorrow in class.